right, and here we are, trying to integrate a non-basic polynomial yet again. We could play the game of course, we could play the game of trying to turn it into a basic polynomial. I guess the only thing I'd be able to do here is rewrite this with an exponent. And that's it. Again, I can't distribute it in. I can't actually raise this to 1/2.
Right. You're done in terms of algebra.
So let me attempt again this u-substitution, changing of the variables. But I got to remember, I have to account for everything in the x world needs to get converted into the u world.
Because you're either in the x world or the u world.
You don't want to be caught in the middle.
You can't be straddling both worlds. I mean, then we're dealing with two variables, and we'll
it's not going to work.
We'll do that in third semester calculus.
Nice. So pick our u. Again, hopefully you've gotten in the habit now of obviously it's the thing with the weird exponent.
Yeah, and I liked what you said before. It's the thing that you would be chaining if you were going in the opposite direction.
So I pick my u, okay, and if you get the u wrong, you'll know midway. I mean, you'll work it out, and the derivative just won't account for the leftover stuff.
Yeah.
To an extent. So I take the derivative of u. Technically, with respect to x, we'll always cross multiply the x on the dx side, the u on the du side. So I have actually just 1 dx.
Okay, so let's see, that takes care of the u to the 1/2, and that takes care of the dx, but wait a minute, Matt, we've got an x there.
This is weird, because again, if I try to, in a way, like, filter my original expression through my u equations, right, trying to think about how they all play out, this would lead me to, I still have an integral symbol, I clearly have u to the 1/2. This is nice when it just says a dx is a du, so I can even swap. Okay, that's good. But again,
still have
there's this x there that I don't want there.
Yeah.
So if we think about what the real problem is here, if we could verbalize the issue, we have an x that we're hoping, or we're wishing it was something with a u. We want our x to communicate some u expression.
So this is interesting, because usually we look to the du to fill in those extra pieces, but can't we go back to our original u and maybe tweak our u a little bit?
This is relating u's to x's, right?
Yeah.
If we had an x minus 5, we could switch it to u. But you guys are good at algebra. You also know this is the same exact thing as if I add 5 to both sides, u plus 5 is x. And that's exactly what I want to have happen here. I had a variable that I'm trying to swap into the u world, but it didn't happen, I don't know, simply with these two equations.
Right.
So I finagled this one a tiny bit, which now is telling me an x is the same thing as u plus 5.
So you're going to substitute in another expression using u.
Exactly. So
how
u
fun.
plus 5 times u to the 1/2 du.
Okay.
Which still doesn't look like a basic polynomial. But the nice thing is, and this is where it gets a little abstract, remember back in the original, I could not distribute my not monomial into my binomial because it had a power.
Right.
It just didn't work here. But by switching around the variables in this way, my thing that now has the weird exponent's a monomial, and it can get distributed in.
So now you can do algebra and expand that out.
So turn that into a basic polynomial.
So
remember to add exponents.
U to the 1 times U to the 1/2 would be U to the 1 plus 1/2. U to the 3/2.
There.
Plus 5. So you're just doing algebra.
Yep.
You just distributed that U to the 1/2.
One common mistake I notice students doing is because I'm messing with exponents in this step, they almost feel like they've done the integration.
Yeah.
But I'm just doing algebra here. I'm just turning this into a basic polynomial.
Right.
I did not integrate yet. And now, number variable exponent plus number variable exponent, that's what a basic polynomial is.
Yeah.
So I could pretty basically now do the add 1 divide.
So 3/2 plus 2/2, that's going to be U to the 5/2.
Divided by 5/2.
Divided by 5/2, which is the same as multiplied by 2/5. Looking good.
That's our 3/2. and rewrite it in the x world.
And just to, so you multiplied that second term times 2/3, and it's 2 times the 5
Right,
gave
5
you the
there.
10/3. Beautiful. Okay, plus your
And then I'm
C.
just going to rewrite it
Yeah, in X land.
with x's there instead of u's.
Very good. So once we get used to that, that's really not that bad. It's just
No, just
getting over the hump of using the U a second time.
Exactly, and recognizing the structure of when one of those three things will happen. Again, it'll work
Right.
out perfectly. That'll be pretty obvious
Right.
because the U accounts for the tricky looking stuff. The DU accounts for all the other bits.
Right.
Off by off by just a number, divide it out, factor it out, and then this last method or process is there was a variable still unaccounted for, but I went back to my original use statement. It all works out nicely. A little extra, few more steps,
A
but
little more algebra in the middle.
yeah, more algebra. So hopefully the calculus concept makes sense, and then just practice your algebra.
Beautiful. Thanks, Mr. Paley.
Good luck.